Okay, so this is the equation for your heat energy balance, which is your Q in minus your QCA minus your QLO minus your QJ minus your QTC minus your QG minus your QR minus your WB. Now this is your energy inputs. This is your energy input minus your energy transferred through the charged cooling air system minus the energy transferred through the lube oil system minus the energy transferred through the jacket cooling system minus the energy transferred in the turbocharging system minus the energy transferred through exhaust gases, and this is the energy transfer. This is the residuary energy transferred minus your brake power is equal to 0. Now at these points we have our different temperatures. This is the exit temperature from the inlets, or you can call it the inlet temperature in the jacket in the charged cool air, that is your T1. Our T2, you can either call it the exit temperature of the charged air or the inlet temperature of the lube oil. Your T3 is your exit temperature of the lube oil, or you can call it the inlet temperature of the jacket water. Okay, so it goes on like that. Now we have our Q in. The formula for Q in is your MF times your LCV. We know your MF will be given in the question. Your LCV will be 42,000 if not given in the question. If it's given in the question, you use the value they give you. Now you have your energy transferred to the charged air after cooling. Now this is equal to QCA is equal to the mass flow rate of water times the specific heat of water, open bracket, your T2 minus your T1. Remember, I have it here. This is the exit temperature minus the inlet temperature. Okay, so we have your energy transferred to the lubricating oil cooling, that is QLO is equal to MW C specific heat W T3 minus T2. The same thing goes for your energy transferred to the jacket's water cooling, that is your QJ is equal to your MW times your CPW, open bracket, T4 minus T3. It goes the same for your turbocharger. It only differs when we get to your exhaust gas and your residuary gas. Now for exhaust gas, now this is at TC. Let's go up here. Your exhaust gas is at T6. Now for exhaust gases, the formula we are using now is your QG is equal to your mass of the gas times your specific heat of gas times your T6, where T6 is the same thing as TG. So mass of gas times your specific heat of gas times your T6 minus your mass of air times your specific heat of air times your temperature of air. Or in cases where steam is involved in the question, we will use the mass of gas times the specific heat of gas times the temperature of gas plus the mass of steam times the specific heat of steam times the temperature of steam, close bracket, minus the mass of air times the specific heat of air times your temperature of air. Note that your mass of gas is equal to your mass of air plus your mass of fuel. So next we have our residuary heat energy. Your residuary heat energy, which is your QR, is gotten by rearranging your initial equation. This initial equation, your Q in minus your QCA minus QLO, rearrange it to make QR subject to formula, then you get your residuary heat energy, which is Q in minus QCA minus QLO minus QJ minus TC minus QTC minus QG minus WB. And you already know that your WB is equal to either your 2 pi n torque or your Planck's.